6'5"?
What's up, Miss Morris?
All right, so here's our agenda for today. We're going to go over our standard. We're going to go over our PBO. We're going to talk about our essential question. We're going to go into our explore activity. We're going to do a summary of learning, and then we'll end with an exit ticket. Journey, can you go ahead and read what Standard 6 ESS 2.3 says?
Construct explanation about atmospheric flow, geographic features, and ocean currents affect the climate or of a region through heat transfer.
Okay, so remember, our standard is the what of our learning. So it's the bulk of our learning. It's what we're going to be learning during this lesson. Everybody go ahead and locate your PBO. So I need everybody to go ahead and locate their PBO. On the count of 3, we're all going to read our PBO chorally. Okay? 1, 2, 3.
Students will be able to construct an explanation about global winds and surface ocean currents in order to compare the heat flow through each.
Okay? Aiden, can you tell me what that word compare means? To note similarities. Lie, can you tell me about the word construct?
To make or form by combining or engaging parts of elements.
All right. Can you go ahead and tell me about the word explanation?
A statement that makes something clear by describing it in more detail or by revealing relevant facts or details.
Good job. Austin, can you go ahead and tell me about global winds?
The movement of air over Earth's surface and patterns that are worldwide.
Okay. Omar, can you go ahead and tell me about surface ocean currents?
A horizontal movement of ocean water that is caused by wind and that occurs at or near the ocean surface.
Okay, so those words that we see annotated are also known as our academic language. Where can we find our academic language inside our classroom? On our word wall. Remember, this is our classroom resources. As we're going through these E's, we have to use our word wall. We have to use our word wall. Where else can we find our PBO? I'm sorry, our academic language?
On our PBO.
On our PBOs. And we also use our PBOs as a resource whenever we're doing what? Good job. Okay, everybody, tell me, what are you all going to know? All right, and how will you all know that?
Checking or understanding questions and teaching.
Okay, good job. What's the cool thing that we have in science that we don't have in any other subject?
Classroom practices.
Classroom practices. What does the blue tell us?
What do they do?
What do they do? The blue is also known as
Science and engineering practices.
What's our science and engineering practice for this lesson?
Construct, explanation, and design solutions.
All right, so it says that you all are going to construct explanations on the weather conditions of an atmosphere. What does the green tell us?
How well do you understand?
How well does the student understand? The green is also known as
Cross-cutting concept.
What is our cross-cutting concept for this lesson?
Cause and effect.
All right, and you all are going to evaluate weather and climate patterns to communicate the cause and effect relationship on climate due to different geographic features. So we'll go into this a little bit today. So again, what is our cross-cutting concept?
Cause and effect.
Cause and effect. All right, Aiden, can you go ahead and read our essential question?
How and why is Earth weather constantly changing?
Okay, how and why is Earth weather constantly changing? Now this right here is our overarching question, okay? This is the question that the district says that we should be able to answer as we develop in our lesson, okay? Okay, so we're moving right along. Today we're in our explain phase, okay? In order to be successful in this phase, you're going to need two things on your desk, okay? So you're going to need your map of Oregon, and you're going to need your rain, shadow, and moisture worksheet. So everybody go ahead and find your map of Oregon and your rain, shadows, and moisture worksheet. Is there anybody who does not have that? If you're having a hard time with the map of Oregon, you can find that map on our student pace Nearpod. So if you need to get on our student pace Nearpod, you can. All right. So if you're having a difficult time reading the map of Oregon, you can access that map on our student pace Nearpod. All right, everybody got that? All right, we ready to rock and roll? Okay, so before we start, we're going to do a quick discussion. Does anybody know any mountain ranges that we have here in the United States? Anybody tell me anything in regards to mountain ranges here in the United States? Miss Lott?
Mount Everest.
Okay, Mount Everest. Anybody else? Go ahead.
Mount Rushmore.
Okay, Mount Rushmore. No? Okay. Anybody else? Aiden? The Rocky Mountains. Good job. Okay, so last summer I actually went to Seattle, Washington, okay? And I learned that Seattle, Washington was called the Rain City, all right? Why do you think that Seattle area gets so much rain? Can anybody tell me why they think Seattle area gets so much rain? Before you tell me, I want you to do a quick turn and talk with your partner. We're going to do 30 minutes. We're going to discuss why do we think Seattle, Washington gets so much rain? Go ahead and start now.
Well, we got that.
Okay, 1, 2, 3. All eyes on me. Thank you, 6'5", for having your eyes on me. Okay? So why do we think that Seattle, that Seattle area gets so much rain? Go ahead. Okay, so it is fairly close to the Pacific Ocean. Can anybody else tell me what them and their group discussed? Go ahead, Aiden. Say it again. Okay, so it's on the side with more water and more moisture. That then causes more precipitation. Okay, good job. Is there anybody who would like to add on, or is there anybody who would like to disagree, respectfully disagree? Okay, Mariah, you want to disagree? Okay, go ahead and add on for me. Okay, so on the left side, we receive more moisture because it's near a body of water. And on the right side, there is less precipitation and less moisture, right? Okay, good job. Can we go ahead and clap it up for our peers? Okay, all right. So now we're going to look at our map of Oregon, and you're going to tell me what major mountain range do you see running through Washington and Oregon State? So we're looking at our map of Oregon, and you're telling me what major mountain range do you see running through Washington and Oregon State? Raise your hand when you found that mountain range. You can also point to it. So as I'm doing my walks, you can just point to that mountain range. And we're looking for the mountain range that runs through Washington and Oregon State. Point to it for me, lot. Good job. Point to it for me, lot. Good job. Good job. Good job. Point to it for me. The mountain range. Good job. Good job. Point to it for me. Looking for the mountain range. Good job. Good job. Turn. Good job, sweetheart. Okay, so what are some effects could the mountains have on climate in Washington DC. So whenever we think about mountains, what type of climate do we associate with mountains? So what's the climate that we associate with mountains? I'm looking for someone over here to go ahead and answer this question. I haven't heard much from you all. So what climate do we associate with mountains? When we're thinking about mountains in an area, what type of climate is typically in the area? Okay, so not landforms, but think about the climate the areas where a mountain have. Journey? Did you raise your hand raised? Okay. So I just want you to think about it. Think about the mountains. Think about what type of weather or climate we hear about or we see in movies that deals with mountains. So have you ever watched a movie and you saw a mountain? Go ahead.
It's possible flood.
Flooded?
It's wet.
Okay, so a wet climate. Go ahead.
It cloudy.
Okay, a cloudy climate. Go ahead.
A dry climate.
You think dry? Okay, it could be dry. Go ahead. Cold. Okay, a cold climate. Snowy climate. You think it'll be hot? Okay, so Austin said maybe a hot climate because it's close to what? Okay, the sun. All right, so now we're going to take all of this information or all these things that we've discussed, and we're going to go ahead and start on our explore activity, okay? So, like I said before, in order to be successful with this activity, we need our map of Oregon, and we need our rain, shadow, and moisture worksheet. Okay, everybody got that? Okay, so I'm going to read the first paragraph. As I'm reading, you're following along. Here's where we are. You know where we are? Okay. You know where we are? You should know where we are. Okay, perfect. All right? As I'm reading, please follow along. All right? A rain shadow is a dry or arid region on the backside or leeward side of a mountain range. The climate is desert-like because most of the moisture from the nearby ocean is released on the front side of the mountainside. The windward or the front side of the mountain range has a wet climate caused by the rapid cooling of moisture-laden air as it moves up the mountain. So what do we know about mountains? So by reading this, what do we know about mountains? How many sides does a mountain have? Okay, 2 sides. The left side is known as the what side?
The windward side.
The windward side. And that's also known as the what side?
The wet
The wet side. The right side is known as the what?
Dry side.
The dry side, which is then also known as the leeward side, okay? So, this is what we're going to do. We're going to take our map of Oregon. Everybody hold your map of Oregon up. This is what it should look like. So we're going to take our map of Oregon. We're going to observe our map of Oregon. We're then going to locate the cities listed below. So now I need you to look at your map. And you should see the same cities that we have on our data chart. So look at your map and look at your data chart. Do you see the same cities?
Yes.
All right. So then we're going to find the name of the city and then locate the amount of yearly rainfall in inches. Okay. So we're going to find Salem. We're going to find Salem on our map. Everybody point to Salem on your map. So go to your map, point to Salem. How much amount of yearly rainfall does Salem have?
47.36.
47.36. Where are we going to write that at? In our data chart on the first box. Does everybody understand how we're going to complete this task? All right. Once you get done with the data chart, you then have 5 discussion questions, okay? So once you get done with the data chart, we're then going to complete our discussion questions. All right? I'm going to give you all 13 minutes to complete this. All right? My timer is starting now. Lot, can you tell me what we're doing?
We're doing the rest of the rain, shadow, and noise workout sheet, and we're doing the lamp and when breakfast time.
Okay, so what we're doing is we're observing the map of Oregon, and then we're then going to locate the yearly rainfall in inches and put it in our data chart, right? Once we're done with our data chart, we'll then move on to our discussion questions on page 2. Everybody got me? Journey, can you tell me what we're gonna do?
We're going to observe the map of Oregon
Mm-hmm.
and answer the question that's listed below.
Okay.
We're going to answer the other 5 questions when we're done.
Good job. All right, my timer is started. You can work with a partner, one person, and you cannot move. All right, so my timer is starting now.
Okay, wait, now you have to. Are you going to say?
Can't go that way. So it's like, what is the pattern that you notice? Discuss with your classmates. Right here. Right to left. You get it? 4, 7, 4, 6, 18, 15, 13, 14.
In regards to your discussion questions, you can use your resources. You can use your student pace Nearpod. You can use your interactive notebook, okay? You can also use your word wall.
The city's on the right. It's not. It's drier. Did I get all that? Oh my God. Okay. The city's on the left is where it is, and the city's on the right. Wait, I said right. The city.
The city's on the left, have the right is on, the city's on the right, have the left.
I already got it.
You just said that, you not just say that you did.
What's up? Boy, I mean, no, we didn't pray. Oh. Now, it's okay. The city
You got the city's on the left, is right, the city on the right, is left.
Oh my God. Because the city on the left is also the city ocean and the city on the right is not ocean. Right. The city on the
You don't.
Okay, you all. So 1, 2, 3. All eyes should be on me. So it looks like that we're progressing faster than I expected. Okay. So we have about 5 more minutes to finish, but it looks like you all are done. So I want to go ahead and clap it up for you all. Okay. So now we're going to do a quick discussion. Okay. You all did well in groups. I heard a lot of talking and communication in regards to weather and climate. Okay? So, what patterns did we notice? So, by looking at the map, what are some of the patterns that we notice? What are some of the patterns that we notice? Okay, Austin?
I noticed that the pattern was going up and down.
Okay, so the pattern was either increasing or decreasing, correct? Is there anybody who has to add on or respectfully disagree with what Austin has said? Okay, Journey, are you agreeing or disagreeing?
I'm agreeing.
Okay.
But I gotta add on.
Okay, go ahead.
The cities on the left is greater than the cities on the right.
Okay, good job. Okay, so go ahead, Aiden. Okay, go ahead and add on. Say it again. Okay, so the Pacific Ocean is on the left side, which is causing an increase of precipitation on the left side. Good job. What may cause this pattern to repeat itself year after year? So why might this pattern repeat itself year after year? Go ahead.
The windward side water cycle, this is because of the windward side water cycle, because it's the only side that has water, since it's closer to the Pacific.
Okay, so think beyond the Pacific Ocean. Think about what we learned about weather and climate. Why do we think a pattern is going to repeat itself year after year? So we're thinking beyond the Pacific Ocean. Now we're thinking in terms of weather and climate. What might cause a pattern to repeat itself year after year? So again, we're thinking beyond the Pacific Ocean. We're thinking beyond precipitation. We're thinking about weather and climate. So what do we know about weather and climate? Weather is what? Weather is what? Short term. Climate is what?
Long term.
Climate depends on a what? A period of time, right? What does weather depend on? A day, right? So what may cause a pattern to repeat itself year after year? The climate. Okay, Austin? Okay, Mariah said climate change. Anybody else? Okay, regional climate. Those are all good answers. All right. Now we're going to look at our map. We're looking at Medford and Lakeview. So everybody found Medford and Lakeview? Why are Medford and Lakeview similar in precipitation rates? So why do you think Medford and Lakeview are similar in precipitation rates? Lane? Good job. There's no mountain range separating Medford and Lakeview. Go ahead and clap it up for our peers. All right? Okay. Which side of the mountain range will receive more precipitation? Is it going to be the windward side and the leeward side, or the leeward side? And explain to me your evidence. Okay? So which side is going to receive more precipitation? Is it going to be that windward side or that leeward side? and explain your evidence to me. Go ahead, Mariah. Okay, so she says the windward side is going to receive more precipitation because it is on the left side of the mountain range, which receives more moisture from the Pacific Ocean. Is there anybody who would like to respectfully disagree or agree or add on? Go ahead. Okay. Okay, good job. You got it. Good job. Okay, so we're gonna move right along. So when we're talking about geographic features, what are we talking? Give me 1 second, y'all. When we're talking about geographic features, what are we talking about?
Landforms.
Which is also known as
Mountainsides.
All right, then we're talking about
Wind.
which is also known as
Cold air, warm air, low pressure, high pressure.
and then we're talking about
Ocean currents.
which is also known as
Equator and poles.
One more time. When we're talking about geographic feature, we're referring to what?
Landforms.
Which is then associated with
Mountainsides.
then
Wind.
which is then associated with
Cold air, warm air, low pressure, high pressure.
last thing,
Ocean currents.
which is then associated with
Equator and poles.
Good job. Go ahead and clap it up for yourself. Okay? So, this is what I want you all to do. We're going to do this for 2 quick minutes, okay? I want you to think about what you learned in the Explore activity. I then want you to do a turn and talk with your partner, talking about how landforms affect local weather patterns. So, we're thinking about our Explore activity. What do we learn from our Explore activity? And then we're going to probe ourselves around this question. How do landforms affect local weather climate? We're going to do a turn and talk with our partner. I'm going to give you all 2 minutes. My 2-minute timer is starting now.
Cold air, warm air, low pressure, high pressure.
Okay, so you have 1 minute and 19 seconds. I really want you all to think deeper, okay? How do landforms affect local weather patterns? We're talking about landforms, we're talking about mountainsides. You all just told me that. So when we're talking about landforms, we're talking about mountainsides. So how do mountainsides affect local weather patterns? Wait,
Okay, go.
not yet.
You ain't even talking.
You all have 50 seconds. I want to hear some strong conversation.
I'm just discussing what I heard.
Okay, so 1, 2, 3. All eyes should be back on me. Thank you, Journey. All right, Lane, go ahead and tell me how how landforms affect local weather patterns. So based on our explore activity, what did you learn in regards to landforms and how they affect local weather patterns?
I learned how to affect local patterns because, like, on one side it can be more moist and it can have more precipitation to make it really wet, and then the other side it can be really dry and never like.
Okay, so making it what? So it has less what?
Precipitation.
And then if it has less precipitation, it has less what? Huh? Rain or moisture, right? Good job. Go ahead and clap it up for Lane. Is there anybody who has to add on or disagree or agree? Go ahead, Lot.
I agree because the left side of the mountain is more moist and it is close to more bodies of water, and on the right side is dry and it's not by bodies of water.
Okay, good job. All right, so we're going to end with our summary of learning. We're going to end with our summary of learning. Can somebody tell me one impact of regional change? I'm sorry, can somebody tell me one impact of regional climate change? Go ahead, Aiden. Geographic features, and when we're talking about geographic features, what do I mean about geographic features? Or, good job. All right, can somebody tell me the last thing in regards to regional climate change? Weather, okay? And weather has to do with what? No. Whether it's whether long term or whether it's short term. Whether depends on the what? On the day. Good job. Go ahead and clap it up for you all. Okay, so we're going to end with a quick exit ticket. You're going to read the question. You're going to write the answer inside your interactive notebook. Okay? I'm going to give you all 2 minutes to do so. So you're going to read the question, jot the answer down, so just A, B, C, or D in your interactive notebook, and then you're going to give me an explanation. So everybody go ahead and open up your interactive notebook. You're reading the question, jotting the answer down, and then giving me an explanation.